Today we're going to go over transformational geometry. These are your transformations. Who can tell me what does it mean to be in a transformation? What does it mean to transform? To change. A transformation is a change. There are 4 transformations: translations, reflections, rotations, and dilations. And I have written everything here that you need to know. I would like to say that you should not lose these notes. You actually need to study these for your STAR test. There are going to be anywhere from 6 to 10 questions on the STAR test asked over these rules, and they are super easy and you can get them correct if you'll memorize what you need to know. All right, so here we go. A translation is who remembers the word for it? Slide. A translation is an adding or subtracting rule. So it is where you take your X and Y, there should be an arrow right here, and you add something or subtract something to the X and the Y. Your job is to figure out what numbers go here and here. And so we'll go over that in just a second. Does a translation preserve congruence, yes or no? Yes, it keeps it the exact same. So if I take something and I slide it over, it stays the same size and the same shape. I need everybody's attention. Does the orientation change? Does your view change when I go like this? No, it stays the same. Special notes. I need everybody's attention. The x-axis moves. Come on, guys. Right and left, and I put that here. The x-axis moves right and left. Right is positive, left is negative. The y-axis goes up or down. Up is positive, down is. So your job will be to drop the numbers here based on what they say. So let me give you a verbal example, and then y'all help me fill it in. If I say it goes 6 left, where would the 6 go, with the x or the y? 6 left. With the x. Why? Because the x-axis goes from left to right. And then left would be plus or minus. So it would be x minus 6. Does everybody understand what to put right there? Yes or no? Okay. Moving on. A reflection. Who can tell me what a reflection is? A flip. Write it down. Put a star right here. This is one you need to study and you need to memorize it before your STAR test. Our STAR test for math is in 3 weeks. Okay? A flip. When you reflect across the x-axis, the x stays the... Everybody look. X stays x. But y becomes opposite. Guys, I need everybody's attention. When you reflect across the y-axis, the y stays the same and the x becomes opposite. Does a reflection preserve congruence? Yes, all it does is take the shape and flip it. Does your view change? Yes. You go from seeing the front of it to seeing the back of it or vice versa. Does everybody understand? And then I have the special notes. When you reflect across the x-axis, x stays the same. When you reflect across the y-axis, y stays the same. All right, a rotation. A rotation is the one that we're going to do the trick called happy face man. All right, 90 degrees clockwise, they're going to switch spots. And the x is going to become negative. 90 degrees counterclockwise, they switch spots. The y becomes negative. 180, they both stay in the same spot, but they both become negative. Now, does a rotation preserve congruence? Everybody look, I'm rotating. Did it stay the same size, same shape?
Yes.
Does it keep the orientation the same? No, my fingertips were facing up. Now they're facing the wall. Does that make sense?
Yes.
All right, a dilation is the only rule that does not preserve congruence. All right, to do a dilation, oh, we forgot, a rotation is a turn. Write that down. Okay, go back to dilation. A dilation makes a shape bigger or smaller. That's why it does not preserve congruence. It is where you take the x and y and you multiply by the scale factor. This says, does it preserve congruence? No. It does not change the orientation, though. So if you were looking at it like this, it's just going to make it bigger. You're still going to be looking at it in the same direction. All right, to find the scale factor, what do? New over old. If you're given the scale factor, it will always be used as a multiplier. If the scale factor is greater than 1, it's going to make the shape bigger. If the scale factor is less than 1, it's going to make the shape smaller. All right, so when you're on your assignment today, where are you going to look when you forget something? Right here. Does everybody remember how to use Happy Face Man? Okay, you have to draw your picture. It has to look exactly like that. Okay, turn to the back. Effects of changing dimensions. If this is on the STAR test, there will only be one question. I won't even be mad at you if you get this wrong because it's confusing sometimes. There's a lot of questions. You better get them right. Does everybody understand? Well, we are going to go over this just so that if you understand it, that's one more question you can get correct. All right, it says modifying a shape's dimensions can affect its perimeter area, surface area, and volume differently. So we're talking about dilating a shape and how it affects it. So this, you'll all see this is a cube, yes? And they made it bigger. So they took a cube and they dilated it. It has an edge length of 2, so label them 2. That means if it's a cube, all sides are the same. So they're all 2. I'll use a darker pen. I should see everybody sitting up and writing with me. All right, it says determine the volume and surface area of the cube. Okay, well, for surface area, we would do pH plus 2b. Everybody agree? So let's do surface area, pH plus 2b. So I need a P, an H, and a B. The height's 2. The perimeter's 2 plus 2 plus 2 plus 2. That's 8. And the area is length times width. 2 times 2 is 4. So I do it in my calculator, P times H plus 2 times B. They're just trying to show you the rules. P times H plus 2 times B. So the surface area is 24. That's the surface area. Now let's find the volume. Volume is just length times width times height. So 2 times 2 times 2. What's 2 times 2 times 2? 8. So this is the surface area, and that's the volume. Now it says, if you double the cube's edges, if you double it, what does double it mean? Multiply by 2. That means the scale factor is doubled, is 2. So 2 times 2 is? These would now be 4. It says what now would be the surface area and the volume? Well, we got to find the surface area, so I need a pH and a B. All right, well, the height is 4. The perimeter is 4 plus 4 plus 4 plus 4, which is 16. And the big B area of the base is 4 times 4, which is 16. So I put that in my calculator. P times H plus 2 times B. The surface area is now 96. The volume is now length times width times height. 4 times 4 times 4 is 64. So how much bigger did we make this cube? We doubled it. What does that mean? 2 times bigger. What it's saying is did it affect the area and the volume the same? And the answer is no, it did not. What did it do to it? All right. How much bigger was the surface area? Divide 96 by 24. What is 96 divided by 24? Anybody? That means the surface area was 4 times bigger. How much bigger was the volume? Divide 64 by 8. Anybody? 8 times bigger. Do you see that the scale factor changed? What was the scale factor when we changed the side lengths? 2. What was the scale factor when we changed the surface area? 4. What was the scale factor when we changed the volume? So, is there something where we're not having to find it all to know the scale factor and how it's changed? The answer is yes. Okay? It says how many times greater is the cube's volume? We already answered that right here. All right, so here's the thing. Everybody look, this is what you need to know right here. When changing the dimensions of a figure to create a new figure, you can just learn the trick for scale factor. The perimeter changes by the same scale factor. So everybody look, what was the scale factor? So the perimeter would be 2 times bigger. The area changes the square of the scale factor. So they took the scale factor and they squared it. So let's go through an example. What was our scale factor earlier? 2. So our scale factor was 2. So the perimeter would be 2 times bigger. The area, you take your scale factor and you square it. What's 2 squared? 4. Isn't that what we got? The surface area was 4 times bigger. Is that what we got? Yes or no? Yes, okay. The volume changes by the cube of the scale factor. So everybody write the scale factor was 2 and cube it, meaning to the 3rd power. What is 2 cubed? What is 2 cubed? 2 times 2 times 2 is 8. Isn't that what we got earlier, that the volume was 8 times bigger? So what am I trying to tell you? They're going to ask one question on the STAR test. One only, hopefully only one. And they'll say the scale factor was 2. How would this change the volume scale factor? And you would just say 2 cubed. If they say how would it change the area scale factor, you say 2 squared. So whatever they give you, if it says area, you square it. If it says volume, you cube it. If it says perimeter, it stays the same. And that's the only thing you would need to memorize for those type of questions. Has everybody got it? Okay, so your assignment will be on paper, but you will put your answers into the Google Classroom to be graded. Okay, leave your computer closed until you're finished.